In this lesson, I'm going to show you how you can collide an object with an ecosystem to make the objects leave the surface. We're going to be using a static population and then adding additional emitters within those objects. So what we're going to do is create a standard terrain to begin with, and I want to change the scale. And we're going to go down to about 150 meters. So I'm just using a standard terrain. And when you're working with the kind of emitter that we're going to be using with a static population, and what we're going to want is the trees that we're going to be putting on here to basically stay put, except when collided with another object. So a standard terrain is going to work best for this kind of population. It's going to cut down on the calculations, basically. Using procedural terrain as a collision object can take a lot more calculation time and isn't exactly necessary. We can put an advanced material on here, or good-looking, realistic material to make a standard terrain look better and look like it has more geometry. What I want to do is just give this a basic material to begin with. What I'm going to do is go to the landscapes and just select the rock and grass, and just to make a modification to it, if we go to the color and alpha tab, just change the function scale down to 1 because it is a little too high. It doesn't look very good at 200. It's just to give us a base texture and something underlying. So it's just not the default surface. And then what we're going to do on top of that is we're going to add the ecosystem particles. And we're going to check particle motion, and I'm going to turn off the fast population mode because some of the effects we're going to be doing won't work with the fast population mode. So what we want to do now is add in whatever we want to have on the surface that's going to be impacted by the object. We could also have multiple ecosystems behaving in this way, and it should react to any collision object that we have. The particles themselves will only interact with those within the layer if you have the collision with other particles turned on. We're not really going to worry about that right now. So what I'm going to do is select plant to add. We're going to go to the vegetation and add a tree. And I'm going to select the alder, which is a higher polygon tree. It should look pretty nice overall. And right now, if we were to scrub the timeline, we're just going to have a huge population showing up and objects kind of falling off, flowing through the object. So what we need to do is turn on collisions for the object itself, for the terrain. But we also need to make sure that it's not emitting throughout the animation. We want to have just one emission, and then we want to be able to basically have a kind of a static population of ecosystem and then be able to manipulate it as particles. So what we're going to do is in the density tab, we can select the first button here, which is to populate only once. If we recompute, now we can see our population. So now if I start to scrub through, what's going to happen is the trees are going to start to kind of move down the slope of the terrain. They are being pulled down by gravity. Now, we can't get rid of gravity completely because we are going to need it to pull the trees down after the collision. So there's a couple of things we need to do. I'm going to go back and edit the material. I also want to make sure I turn off the disable indirect lighting, which is turned on automatically whenever you create a particle-based ecosystem. So I'm going to turn that off because I do want to have indirect lighting affecting the terrain, and that it does affect only the material itself. of the object and not the ecosystem or instance materials. Those are independent, and you can turn that option on or off by going into the materials for the ecosystem. So one thing we need to do is remove the velocity from the tree. And we also need to double-click on the instance to open up the particle characteristics so we can enable an attachment force. What this is going to do is stick the particle to the emission object until a certain force is reached upon the particle, and then it'll dislodge itself. Another thing we should do at this point is to increase the mass of the object. So I'm going to go ahead and bring this up to just 3,000 for the moment. Recompute. Still seeing a lot of the particles moving downward. That's because the attachment force isn't high enough. Also keep in mind that when you populate on steeper slopes, it's going to encourage that. If we go to the particle layer, some of the settings brought over from the rock and grass, or have been brought over from the rock and grass, we do need to manipulate the presence. So I'm going to get rid of the fuzziness in the top and bottom, and get rid of the fuzziness on the steep and flat areas, and also make sure that we are populating on the flat areas of slope. We can also bring this up if we only want to populate on flatter areas. And then what we can do is increase the density of the initial population, and that'll help stick it to the surface a little more. And we still have the particles really kind of flowing down. So what we can do is increase the attachment force. Well, another thing we could do is have the adhesion coefficient turned on, which will also help stick the object. And now they're sticking a lot more. The only problem with using the adhesion is that sometimes the collision object, as it impacts the terrain, what will happen is the ecosystem and the particles will start to stick to the collision object rather than kind of bouncing off of it. So a better thing to do in this case would be to turn up the attachment force and see if we can get the particles to stay still that way. And it looks like they're still kind of flowing down there. So what I'm going to do is turn on the adhesion and just set it to 100%, and we can bring that back down for the attachment force. Different trees and vegetation are going to react in different ways. So sometimes you need to have some objects using the attachment force and some using the adhesion. So you just kind of got to balance it. And as you can see, as I start to scrub, we are losing some of the objects around the edge. That does tend to happen with certain terrains, most terrains really. Around any population where you have it populating right on the edge, a lot of those will start to go. So what you really kind of want to do is maybe give yourself a little bit of time between the initial start of the animation and when you're going to render. So in this case, it looks like it takes about 2 seconds for those to go below the terrain. So we could maybe start rendering at 2 seconds and just have a little bit of delay on the object impact. Another thing I want to do is just go to the ground, and we can turn collisions on for that. And now we can see that those edge emissions are now staying still because they're starting to collide with the ground plane. So if you have an object, as we do in this case, with the ground intersecting with the edge, then you might not have to worry about it. But you won't necessarily have the edge in view, so it doesn't really matter too much. So what we're going to do now is we're going to use just a basic object. We want to keep it as simple as possible, at least to create the collision. Now what we can do is we can swap it out later, and after we bake the particles we can change it to any object we want. The less complex an object is, when it collides, the faster the calculations are going to be, and really it's going to end up being a little more accurate in some cases, because what will happen is if you have a very complex object, the particles will really stick to it and sometimes get stuck inside the object. So I'm just going to make an adjustment to the atmosphere and just bump up the sun a little higher. And adjust the azimuth. Go to the sunlight and just bring down shadows to around 80%. You can also go ahead to the ground and load that rock and grass material onto there and reset. And give it a slightly different name. Just put ground in front of it, just to make sure that those are staying separate. Okay, so what we're going to do is we're going to have an object coming in, going along the x-axis, and if you're looking at the camera view, it would be from left to right. So what we'll do is just go ahead and add an object that's going to be our collision. We're just going to use a sphere. We want to enable collisions for it, and we're just going to move it off screen. So now what we need to do is just set up keyframes for how long it's going to take for it to pass across the surface or collide with the surface. We can lift it up. If you want to say we're going to have an asteroid or something crash into the terrain, this is just going to represent the asteroid, and then we can swap it out for a higher res rock model after we've baked out the animation. So what I'm going to do is just have a short duration between the position keyframes. We want it to move fairly quickly so we could have it impact within and move from its current position down slightly below the ground plane in about a second or so. So what I'm going to do is go to the motion tab for the sphere, and we're going to select basic for the motion. That's going to automatically add keyframes to the starting position, and then I'm going to leave auto keyframing off for now and just scrub a little over a second into the animation, and then move this object down slightly below the ground. Right click, and we're going to add a position keyframe. So now if we take a look, we start to scrub through. Now beyond 1 second, the animation for the particles is set to automatic. So what it's going to do is take whatever keyframes are set up in the animation and make that the end of the timeline. What I'm going to do is manually set that up so that we can go beyond the calculations, just the keyframes. Another thing you can do is just place an object underneath the ground plane that's not really going to show up in the render that has a certain keyframe at the end of the timeline. That's another thing that works. But I'm going to turn off the automatic animation range, and we'll just set it to, say, 5 seconds. So 0 to 5 seconds. I'm going to change my simulation rate to 30 Hertz. So now if we take a look, we can see once we have the impact, the objects kind of fly off and then they start to fall down. Depending on their weight and the speed of the impact, and also some of the other settings that we set up within the particle characteristics. Now if we take a look in the top view, we can see the impact area and what's happening to all of the instances. You can see them being cleared wherever the impact area is. So if we want to make some adjustments, let's go ahead and, if we change the mass to 300, and now scrub through, we'll notice that the objects don't go nearly as far when they're impacted. So now we have them just kind of hanging in the air a little bit before they fall to the ground. So we can adjust that depending on how far we want them to go. We can just change the mass, which is the easiest way to adjust that. So let's go ahead and bring it up to 1,000. Make sure I recompute after making that change, just so they show up properly. Now one thing you'll notice is they're standing, pretty much all the objects are standing up and down, straight up and down, which is not very desirable. We want them to change their orientation. So what we can do is use the motion blur setting for this, actually. First I want to just go ahead and do a quick render what it looks like right now. So here's a render of the current frame. As you can see, all the objects are pretty much straight up and down after being impacted. So what we want to do is enable the motion blur, not to actually blur the particles or blur the objects, but to change their orientation to match the path and the motion path they're going on, which is a neat little trick you can do. So what we can do is we can edit the global particle configuration just by going particle motion edit, turn on motion blur, and set the blur amount to 0. So we won't have any rescaling of the objects this way, but it will change their orientation. Now it may not show in the preview for the instances, but when you render, you will be able to see that. So I'm going to go ahead and render the current frame, and we should see a little more rotation now, depending on the speed of the objects are being knocked off the surface and where they're at in the falling stage. So it's definitely better than it was before. As you can see, some nice rotations. It looks a little more realistic that way. And as they start to fall, we should also notice them being tilted more towards the direction in which they're moving. One thing I'm going to do right now is go back to the terrain and increase the density. We've got 518 instances right now. Let's increase it. Right now we've got 4,300. So they're really packed in there at the moment. And as we scrub through, we can see this huge section just being sort of obliterated. Just so we can see more of the rotations and those kinds of changes from the impact. I'm going to render another frame. Now we don't have quite the rotation that I wanted of this, and we could use effectors in order to add spin or rotation to the objects that way, but what we should be able to do is turn on the 360-degree population and just go over to the scaling orientation and make sure the direction from surface is set down lower. And that might give us a little better rotation. Another thing we could do is just go into the characteristics and set the blur amount maybe just to 1. And we'll see if that helps at all. And that's looking a little better now. There's more oriented to the direction in which they're traveling. And the only thing about this is once they hit the ground, they will stand straight back up. And one thing you can do to make them sort of stay on their sides a little bit is to make sure that when the particle hits the ground, that instead of just staying completely still, it starts to maybe spread out a little bit. Even the tiniest bit of motion would change the particle's direction. So right now, once they hit the ground, they pretty much stick. But we can turn on the drag coefficient, and that can help. I'm just going to turn on the density, bring it down to about 1,000 instances, just so we can see this a little quicker. And it might be the adhesion that's causing it to stick, or the attachment force. So you may have to just kind of keep some of the fallen ones out of frame somewhat. Or what you can do is another thing is set up a little bit of elasticity with it. And they'll bounce, but the motion might be somewhat useful. So now, instead of just hitting the ground, they kind of bounce a little bit, but it does change their movement, so it might fix the orientation. And every instance in different types of vegetation will behave in different ways, depending on the scale of the object and where the root system is. There's a lot of things that can affect the way the particle motion is applied to each instance. So some of them are turned over a little now as they impact with the ground. One thing you notice too is that they're going about halfway through the ground, and that is a result of using the drag coefficient. That'll basically adjust the range, how far it goes through the collision surface. Now another thing we can do is, let's say we want to have leaves maybe flying off the objects after they're struck and impacted and kind of flying through the air. So what we can do is set up a particle emission, or periodic emissions. Because if we were to use this based on collision and have it emit any other smaller vegetation to act as leaves, the collision itself from the sphere object is not going to count as a collision. So that initial collision right here, where we have the particles accept themselves when you go into the characteristics tab, that doesn't count as a collision. The what will count is when it hits the ground on its way down. That's going to count as the collision. So what we need to do is set up something a little more advanced to trigger the periodic emissions, because we don't want it just emitting lots and lots of leaves as it's stationary. We just want it to start to emit leaves as it's flying through the air. So what we're going to do is we're going to use the velocity of the particle itself to control the periodic emissions. So what we're going to start out with is opening up the particle characteristics for the alder, and we need to pick an object that we want to be the leaves kind of emitting from the object. So we're going to load, and we have to load, in this case, an object. So I'm just going to cancel that out, and what we want to do is go into the main emission, and we're going to need to load another plant that we want to use. And then we can just set its presence down. So we're going to load a plant and pick something we want to use to emit. We can use just one of these smaller plants, or we could use even the bush species to create a lot of objects. Let's use the sorrel species and see how that's going to look. So once it's loaded, it's going to ask if we want to give it a different name. I'm just going to keep the default name. And if we go back, what we need to do is change the presence to 100 for the alder, because we don't want the other object actually populating on the main ecosystem. We just need that in order to get it into the periodic emissions. So we double click on the alder, and now we can go and select that plant and set it for the periodic emissions. And we should start to see them being emitted. And trailing along. I'm not really getting a preview right now. If we set this to billboard, you will notice sometimes the child particles don't really get a preview. They'll just be dots. So it does look like they are showing up. I'm just going to do a quick render just so we can see them. And we can see all those little small plants being emitted. So what I'm going to set up now is to control the periodic emissions, because right now it's just every second it's going to be emitting those particles. And I can't really tell if they're falling or not either. We can see the emissions being created, and it might just be the preview. So what I'm going to do is just double check, and we can scrub back a little bit and take a look at the render preview, and just to make sure that those objects are falling, because gravity should be affecting them. It does look like they are falling down. It's just the preview itself that's a little bit off. Okay, so what we want to do is go into periodic emissions, and we're going to drive the flow with a function. And what we're going to use is we're going to add, right-click, add input node, and select particle speed. Now this is not going to be the child emission speed. This is going to be the alder species and whichever is the main particle. So we're going to use the speed from that. What we're going to do is add in a math node, vector operations, length. This is going to take the vector total and give us a length number output that we can use. Now, because of the nature of this, we're not going to get an output preview within the node preview. So we're going to have to scrub the timeline in order to see the results. So what I want to do is set up kind of a fail-safe by adding a filter and setting it to ceiling and setting the max amount of emissions per second, and we'll set it to 20. And this way we don't end up creating thousands and thousands of particles depending on the velocity that's set up. So if we just set up a ceiling, we can make sure that we have a little bit of a fail-safe. And we're not quite ready yet with all of the emissions. So we do have a couple of things, a couple more nodes that we need to set up. And basically what we need to do is subtract a velocity in order to set this up properly. So we're going to go back into the settings and the function for this, and we're going to add a combiner node, set it to subtract. We're going to connect the length, and then we're going to subtract a constant number. So we're going to add a constant node, set it to constant number, and let's go ahead and set it to, say, 3. So we're going to subtract a velocity of 3 from the main velocity, and that should allow us to only emit once the particles are in motion. And I'm going to add another filter and set it to floor with 0, the default. Connect that to the subtraction, and that way we're not getting negative numbers. And we'll see how that's working out. So now we should only have those periodic emissions once it's in motion. And one way we can double check is to open up the material, and if we take a look at the amount of instances there are, that number will go up as they are generated. So if we start to scrub the timeline, we can see that the amount of instances is staying exactly the same up until the collision. And then once those particles and the alder trees are in motion, they start emitting the other particles. Now I do want to set up a velocity. I'll go ahead and set it to 4 for the max velocity, just so it's not those strings that are coming out. But we may need to adjust the weight of the species. So I'm just going to increase the mass to 5. And I'm also going to scale them up a little bit and bring them up to 3, because right now they're really hard to see. They're very small. And that might be why they're behaving so strangely. And not really seeing them fall too quickly. So what I'm going to do is set, under the periodic emissions, the velocity. Let's go ahead and set it to -10. Let me see if that helps at all. If not, what we can do, because right now it's just creating these kind of streams, and I'd really rather have them kind of flying off the surface a bit more. we might be able to do is go to the specimen and turn off inherit emitter velocity. But they might be sticking because of the adhesion to the other particles. But one thing I know we can do is go into the particle motion and increase the turbulence, which should only affect the lighter weight objects depending on how high we turn up the turbulence. So that is spreading them out a lot more, and it shouldn't affect the heavier objects nearly as much. And if we need to use a different plant, it might work out a little bit better. Maybe we could use a bush or something, which I think might spread out a little bit more. So what I'm going to do is just swap that. And what we can do is double click on the object we can replace by tree. And I'm going to go to bushes and select the bush one crawling. And we might just need to scale it down a little because it's going to be increased with that initial size. And probably turn down the ceiling for the amount of emissions. We can adjust the weight too. Because right now it's just creating this kind of stream. And another thing we can do is go to that periodic emissions, and let's just change the velocity to 50. And we might have to go a lot higher than that and try 500. And it looks like it's just not quite reaching or spreading out as much as I'd like. So what I'm going to do is decrease the amount, of course, that's being generated. So what we can do is go back into the species, adjust the flow, and I'm going to change the ceiling to, say, 5. I'm also going to subtract maybe a little bit more so that they're not being generated until they reach a little bit of a higher speed. It does look a little bit better. So now they're not immediately kind of flowing off of it, but it just takes a tiny bit longer. And I am going to turn back on the inherit emitter velocity. Turn down the mass maybe. What we could also do is turn up the mass, and that might help the velocity itself. So let's go ahead and set that to 500 and see what happens. They should be spreading out a lot more now. There we go. And it was mostly just the mass being way too low, and we weren't seeing enough of that velocity coming through from the periodic emissions. So what I'm going to do now is just take the turbulence down a little to 0.2. We can go back and scale this plant down a little more, cut it in half. And we might need to change that velocity since we had it up very high before. So go into the periodic emissions, change it down to 100, and see if we can still get it looking good. And it looks like we can probably bring that down a lot further because it was just the mass. It was too light before to react to the velocity. So there's shooting out pretty quickly now. I can even bring that down probably further and still get it spread out more. So now if we want, we can maybe bump it down a little further in the scale. And then also we can increase the emission count up to 10 once it reaches the proper velocity. And they're flying out pretty quickly at the moment. So let's bring that velocity back down. Oh, and that's because the other one was set to 100 still. So we need to make sure that our negative is also brought down. And there we go. It's looking better. If they're flying out too far beyond the other object, you can adjust the weight. Right now we had it at 500. Let's bring the mass down to 100. And if that's not quite enough, we can do maybe 200. Just enough to spread them out, but not so they're going too far beyond the surface. Okay, so another thing we could do is we could also add some rocks into the ecosystem. We'll just use the county carry rock, add that in. And I'm going to change the presence down to about 5. So we don't want a whole bunch of them. We'll increase the mass and the attachment force. And we'll add the adhesion at 100%. And now we should have some rocks in there as well, being populated and kind of flying off. You can see one of the rocks right there. And we could increase the count if needed. But one thing I'm going to do, actually we'll go ahead and bring that to 10. And then I'm also going to increase the density up to 93 for the initial density. Recompute. And it's going to give us a lot of rocks, so the instance count is going to really shoot up. So we might need to change the presence. Let's bring it down to 2. And might need to just bump the density down. So now what we can do is bake the ecosystem. So we can go into the ecosystem, select bake, select, I do need to change the amount of frames per second I have here. So we're going to go to animation, animation render options. I'm going to change it to 30 frames per second. And animation in view is time-based, so it will just add the additional frames between the keyframes. All keyframes are time-based, based on seconds and not on frames. Functions are basically the same way. So I'm going to go in, and now we're going to bake just 5 seconds. Okay, so now everything is baked out. And once the motion is baked, what we can do is turn off the rendering of the sphere. So now that sphere won't show in the animation. And then we can add an object and set up new keyframes if you want. or you can have it just follow that object, the sphere object. So let's go ahead and load in an object that we want to use to collide with. We'll use North Rim Rock. Just load that rock in. And I'm going to go ahead and scale it up. Just kind of match it to the size of the collision. And then what I'm going to do is just set up a graph, just connect it with the graph, and we're going to go to position for the input and select that sphere position and connect the position output to that position. So now they'll be linked, and we can see the more complex object colliding. And it'll look a lot better. What we could also do is set up a little bit of rotation. So what we could do is go to the motion tab and set the motion to just basic, and then go to the animation toolbox, and we can set up a spin. And now it'll start to spin as it goes into the surface. And that way it's got a little bit of motion to it. So just as long as you don't make the more complex object a collision object, you shouldn't run into any problems, because like I was saying, a simpler object does work best. Another thing you could do is use, instead of a sphere, you could use a cube object as a collision object and have it rotating when it hits, which can knock instances around in different directions, and that can be pretty neat and give you some pretty neat effects that way. So you can also set up additional ecosystem layers, and since we already have this other object animated as a collision object, once you set up other layers the way the current layer is set up, then you can add additional rocks or vegetation. Just stay away from stacking stacked ecosystems in this setup, because the objects that are stacked will immediately start to fall, regardless of whatever adhesion and attachment force you have set up. Typically, they'll just start to kind of fall regardless, unless you have particle interactions with each other set up, which can sometimes prevent that. But that's a neat little thing you can do here with fixed populations. And get some pretty neat effects just from basic collisions without having to set up any extra effectors. And then, of course, you could have it emit other particles as well if you wanted to have maybe dust or kind of smoke in there and different grit. You could add that to the periodic emissions as well. Upon rendering the animation for this scene, I ran into a couple of issues with Vue, and I just want to go over those points right now, and also just a couple of things about periodic emissions to increase the emission flow. First of all, when I created this animation, I was working with 30 frames a second. The default for Vue is 25 frames per second. And when I baked the animation, even with a proper frequency, or the hertz setup for the animation calculation per second, I ran into a little issue, and I'm going to show you right now. Basically, if I scrub through the timeline, and I do have it baked right now, and go through frame by frame, what we're going to notice is I'm at frame 15 right now. I'm going to go to frame 16, and we start to see the trees being collided with the sphere. And at frame 17, the sphere starts going in further, and those trees don't move. So the movement from frame 15 to 16 for the trees is identical. And now I'm on frame 17, and they're pretty much in the same place for at least 2 frames. And I noticed that happening in a couple of different places. So now the movement from frame 17 to 18, we can see the trees are moving. And then when I move to frame 19, there's no movement. And then so I move along, I was noticing that was happening up until a few seconds into the animation. Then frame by frame, everything was working. Now the only way I was able to really get around this and actually have movement frame by frame like it should be is I wasn't able to go in to the motion options and change the simulation rate. That no matter what I did with that, it had no impact whatsoever. So what I found what you're going to have to do is definitely work and plan things out frame-based. That's going to cause some problems with the dynamics, mainly because if you look at gravity, it's based on seconds. So I'm going to show you how you can compensate. First of all, what you want to do is go to the animation and show the time as frames. Make it a little easier to work with. Another thing you want to do is set the animation render options to 25 frames per second. Now, in most cases, you'll be rendering out in as a sequence, individual images, so the frame rate itself doesn't really matter for the output because it's all just frame numbers. And then what we can do, and you can even see just by changing that, even the current baked animation is working better. So now also when you bake the animation and first set the simulation rate to either 25, which is going to be 25 calculations per second, or you can set it up to 50. I like to at least double it sometimes, depending on the complexity of the animation. And then when you bake it, you can bake at 25 frames per second, and you're going to have to calculate the start and end time since they're going to be a little different, because now it's going to be based on the frame rate. There's one other thing too, and what you're going to need to do is calculate the difference for the gravity, and also some of the other particle options. So I've set this to 25 frames per second, but I really am going to be outputting it as 30 frames a second. So what I need to do is adjust the gravity to match the time frame properly. And what we can do, and this will apply to basically all of these settings. Most importantly would be the gravity and also the setting up the drag force. And all you need to do is take the default frame rate, which is 25, and divide it by the new frame rate. So in this case it would be 30. And then we can take that number and multiply it by whichever one we're trying to calculate the difference. So if we wanted gravity, we could just multiply it by 9.81. Of course, we're working negative, so we can just enter the value negative. So then our value for 30 frames per second would be 8.175. So then we could do the same thing with the drag force, which is 1.2. So then we could just 25 divided by 30 times 1.2. So then we could just bring it down to 1, because the difference between 25 and 30 is 1.2. So that actually makes it really easy for that one. So that's one way we can adjust and kind of compensate for those seconds, because otherwise you're just going to have a jumpy animation. I really was not able to find a way to correct that properly. You may be able to bake the frames at 25 and have the playback work properly, but to really make sure everything's consistent and doesn't get you at the last minute, you kind of want to set that up ahead of time. If you're going to use this method, another thing you need to keep in mind is that the life durations are going to need to be modified for the particle characteristics, not specifically to the scene because we don't have lifetime set up. Everything just lasts throughout the animation, is not destroyed because we have the populate only once setting turned on for the density. So we just basically have a fixed amount of instances besides the periodic emissions. If you have any functions that are time-based that will be affected by this sort of change, a really easy thing you can do, and I'm just going to create a function here really quickly. Just before you make any connections to the time, just all you need to do is add a map node just after the time input, and then connect all of your functions to this map node. What you want to set is the lower value 0 to 1, and set the upper value. And what we could do is just have this calculated within the function. We can add a combiner node, set it to divide, and we'll take that constant node and connect it to the division. Connect that constant, and we're going to reset that so it's not a slider. Constant number, and we're going to add another constant number. We're going to set this one to 30, so that's the output frame rate. Set the first one to 25, which is the default, and that's going to give us our 0.8 or whatever output that we have, and automatically convert the time over to that, so then everything will match. So all you got to do is set this up before or immediately after the time input, and then connect anything you have dependent on time to this map node, and then everything will match up. So that way you can make sure you don't have the glitchy animation, and you can still time things the way you want them. I'm going to go ahead and cancel this out and disconnect that. One thing I wanted to show you that I didn't completely cover before was how to increase the emissions. Basically, I set up a ceiling so that the max amount of periodic emissions was taken care of for the trees. But it's not necessarily going to reach that max amount. So if you do want to define a higher value, you can just use a map node to set that up. And what we're going to do is just go into the terrain and the ecosystem, go to that periodic emission, and go to that flow controller. And what we can do is just add a filter, set it to map, and we'll set that in between the floor and the ceiling. And what we're going to do is just set 0 to 1, and then we can set this upper value. We can extract it and also extract the ceiling so that they're the same. And then we can set the output to basically the desired value. Let's go ahead and set it to 15. And now this is going to do 15 on average per second. So once again, if there's calculations to be done based on that frame change, in most cases with this kind of stuff, you can really just kind of guess up or down because we're not looking for exact values. But the most important one in this case is going to be the upper value for the input range. And what we're going to do is basically say a velocity of 1 is the max that we can reach. And once we hit at least a velocity of 1 meter per second, or the default seconds, then we can generate up to 15. So we should now have a much higher emission rate. And if you need to lower the value, you can. And I'm not sure if it's generating quite enough. So what we can do is bring that down to, say, 0.2. And we can increase maybe to 30. And bring it up really high. Because we have a fairly short animation. And now we've got a much higher emission count for those bushes that are coming out of the alder. So that's one way you can make sure that even if the velocity doesn't get high enough to emit a high number, because before it was basically just controlled by the length output of the velocity. And this way we can just take a map and just say, well, 0 to 1 is going to equal this amount no matter what. So as long as we go above the subtracted value, which is set to 10, so we're subtracting a velocity of 10 from it, so that way still when it's stationary it's not emitting, but once they start coming off, we can very quickly emit up to the desired value that was connected to the ceiling. And I just went ahead and baked it at 25 frames per second with the animation output set to 30 frames a second just to see if that would correct it. But it is still having pause issues where there's just no movement for at least 1 frame, and that is really going to look terrible. And one thing I noticed when I was rendering it out when that happened, there were basically transparent trees where the movement should have been in some places, and the rest was kind of fixed, and it just did not look right at all. It was really glitchy. So I would definitely say you have to render at 25 frames per second in order to get it to not be glitchy, because right now it seems to be baking based on that fixed frame rate and the default at 25. Hopefully you can get that fixed sometime in the future, but for now you can just use those calculations I showed you to kind of set things up properly and animate within the actual time frame that you want. And just one last note about the particle motion blur that I was using to orient the instances along the direction of the velocity. That does somewhat change depending on, if we go to the ecosystem and go to scaling and orientation, the rotation setup that the population is initially fixed at. There's a rotation where it's a random rotation up to 120 degrees. This can also affect the orientation when it first comes off of the surface. So if you want to have an exact orientation along the velocity path, or the motion path, then you can remove this rotation, and that will correct any random rotations that you have or that you're seeing or it doesn't quite look right. Generally for this kind of animation, you should be safe with a random rotation. If not, you can just select a different orientation or set it down to 0, and that way they'll conform a little bit more to their motion path. You can also change and add a little bit of the perpendicular direction from surface in order to kind of have it angled a little more. So just some extra little tweaks that you can do. I also wanted to make one last note about the ecosystem material for the bush. And I already made this change not while recording. What I did was I took the alder species material and applied it to the bush so that the leaves would match as they're emitting off of the alder species while they're flying through the air. And I wanted to show you a quick way to transfer the materials between the ecosystem particles, because you can't just directly copy and paste them in, and sometimes storing them in the material editor doesn't always work. So what you can do is and first I have to clear out, I do have an object in here already set up for this. So what you do is just take the material that you want, and this is the leaf tree natural, and that's what's on the alder species. And we can right click and copy the material, and then I'm just going to add an object to the scene, just a sphere, and paste that material to the object. That way, when we open the material summary, that material will show up in here. That's important because the ecosystem materials won't show up in here, and we do need that. So I've just renamed, I already copied and pasted onto this object, but I renamed the surface back to the original name, which was green leaves, and that's what was applied to the bush species. So now what you want to do is double click on the species or the material that you want to change, and what you can do is just go into the material summary and just drag it onto the preview, and that will update and apply that surface. And then we can click OK, and then it'll update the ecosystem preview. And that way you can move materials around a little bit easier. You can also store them sometimes in the shelf over here, but that doesn't always work. And the options for it are sometimes grayed out. So the easiest way is just to copy it, copy the material, just quickly add an object to the scene that you're going to end up deleting later, and that will make it available in the summary, the material summary, and then you can just drag it onto the surface to apply the material. And that way I was able to make all of the leaves match, so they weren't really bright green, which is what they were by default.